Hello and welcome to Quantum Software Engineering with Quantum Path on AWS. My name is Nihit Pokhrel and I'm a Partner Solutions Architect at AWS. In my role, I work very closely with ISV partners for building solutions in the high-performance computing and quantum computing space. I am joined today by Pepe, who is founder and CTO of aQuantum, an AWS partner developing solutions in the quantum computing space. In the next 30 minutes or so, you will learn about aQuantum and see a live demo of Quantum Path. At the heart of Quantum Path lies Amazon Braket. Amazon Braket is a fully managed quantum computing service that enables researchers and scientists to design, test, and run quantum computing algorithms. Amazon Braket provides on-demand quantum computing resource, and you pay only as you go, without any upfront commitment. Now let's talk about the hardware that is available through Amazon Braket. Through Braket, you have access to quantum simulators as well as real quantum computers. You can use our managed simulator. Currently, we offer 3 of those besides our local simulator: State Vector 1, State Vector Simulator, also SV1, Tensor Network Simulator TN1, Density Matrix Simulator DM1. Amazon Braket, like I said before, also provides access to actual quantum machines. Following the gate-based quantum computing paradigm, you can access machines from IonQ, Rigetti, and OQC. Alternatively, you can also choose quantum annealers using the latest QPUs from D-Wave. You now also have the option to use Borealis device from Xanadu, which is a photonic programmable quantum computer. The availability of different types of machines help you test different technologies, compare and contrast the compute performance of different machines for the problem that you're trying to solve, and really choose the hardware that is best suited to solve your application at hand. One thing to be careful about is that devices are available only in select AWS regions. When you're ready to run your quantum algorithm on Amazon Braket, do look out for device availability. To get started, Amazon Braket comes with example notebooks, tutorials, and tools, such as fully managed Jupyter Notebook, which you can use without the need to set up and manage any infrastructure. You can also install the Braket SDK and work in your own local development environment. You can also directly use the AWS Management Console. From the console, you can control the task and check different hardware availability directly as well. In the fullness of time, Amazon Braket will continue adding more quantum computing platform and technology and make them available to our customers. Now switching gears back to aQuantum. aQuantum software as a solution, Quantum Path, uses Amazon Braket to not only provide access to different quantum computers with different modalities, but also to make the creation of circuits easier. Quantum Path provides a complete pipeline to create industry-ready quantum software solution. Using Quantum Path, you can create circuit definition and Kubo formulation through an intuitive, code-free, interactive platform. Quantum Path takes care of translating from the GUI into an optimized code and connects with the quantum hardware provider of your choice. As an end user, Quantum Path also keeps you in the loop by providing you notification throughout the process as you go. If you're new to quantum computing, you can explore annealing for optimization problems and also evaluate different quantum gate across a variety of quantum devices without really having to worry about the infrastructure or the machine downtime or licensing with the quantum hardware provider. Truly, you have quantum computing on demand, and you only pay for what you use. Your data is secure, and you can also have strict control over the access of quantum circuit following AWS best practices. Quantum Path continues to evolve, providing the best customer experience and lowering the barrier to entry for quantum computing. With that, it's my privilege to hand it over to Pepe to talk about aQuantum and Quantum Path in greater detail. Pepe, over to you.
So, hi Nihit, thank you very much. and thank you very much to Amazon for this opportunity to present our company and Quantum Path as our technology. Okay, first of all, let me present the company. At the end of 2018, Guido Petersen, myself, and Mario Piatini began to research the state of quantum technology and its potential for adoption in real IT. In 2019, A-Quantum was founded as a result of the collaboration between Alarcos and Alhambra IT, converging knowledge and know-how in the classic IT world for more than 30 years of experience. In 2020, we started Talavera Manifesto. This manifesto collects some principles and commitments about the quantum software engineering and programming field, as well as some calls for action. This is the result of the discussion and different viewpoints of academia and industry practitioners who joined at the first international workshop of quantum software engineering and programming, Q-Answer, promoted by A-Quantum. Since then, it has been participating actively and continuously in major events and providing innovative technologies and projects. Quantum Path appears in the market as the first platform for the development of quantum solutions, and the amazing Q-Health project, Quantum Pharmacogenomics Applied to Aging, in which Quantum Path is selected as technology. Since 2021, the A-Quantum brand is consolidated as a company dedicated to business services around quantum technology, and Quantum Path goes into production in Amazon AWS services, as well as its bracket services are integrated into the supported set of quantum provider subsystem, taking Quantum Path to the next level. During this time, A-Quantum's network of partners and customers is expanded and services are consolidated around Quantum Path technology, which continues to evolve and grow and contribute to the rapid adoption of quantum technology in the real world. Proven services and technologies such agnostic life cycles, designers like the Quantum Asset Compositors, agnostic QAOA and QSOA, to name a few, add value to those who want to early adopt quantum technologies in their business. Thanks to the relationship between Amazon and A-Quantum, we are prepared for the next challenges to come. We encourage you to visit our websites, from which you can learn more details and access our services. A-Quantum is a company that aims to accompany our customers in the adoption of the quantum technologies in their business. They are technologies that are emerging, and there is a road ahead, of course. But there is already much progress, and certain quantum technologies can add value to companies even without being 100% mature. With this idea, A-Quantum provides research and development lines applying to. It provides knowledge IT teams, and it's reinforced on the basis of multidisciplinary collaboration, physicists, mathematicians, of teams that work together to solve problems where quantum technology adds value. Apply quantum technology by design in hybrid classical quantum environments, where QSOA technology can provide a clear integration interface between technologies. It exploits the capability of the Quantum Path product to take to the next level the software engineering process that uses quantum technology as a resource for the creation of quality solutions in the business. And it seeks to solve new use cases, designing and applying quantum algorithms that solve business problems. As great results of this work, we have an example of the Q-Health project. This research can let us to study how to apply the quantum technology to be used to give more quality to our elders, for example. It's an amazing project. At the end, we have to talk about the A-Quantum Partner Network. The Q Network is the network of institutions and companies that collaborate with A-Quantum to pursue progress in the adoption of quantum software engineering and development best practices. Through collaboration in quantum activities, in quantum research and development, the implementation of practical quantum products and services, training and competences development of the quantum software workforce, the dissemination of quantum knowledge through courses, conferences, documents, events, and the development of quality quantum software according to the principles of the Talavera Manifesto. So this is the introduction of our company. So you can see we are totally involved in the early adoption of the quantum technologies in the real IT. Okay. Next, if you let me do that. I will present our technology with a few examples of how to use the tool. Okay. First of all, we demonstrate how to connect our technology with the Amazon Braket infrastructure, and then we began to create a circuit based in the gate technology and explore an annealing circuit to see how easy is create some kind of assets in a quantum solution. And then we explore the QSOA SDK to integrate all these kind of assets in a classical system. So let's begin to access Quantum Path. So let me introduce the access of our web pages. From iQuantum.s or QuantumPath.s, you can access to the main page of Quantum Path. Okay, through this main page, you can log into the system, and with your user and your role, you will access to different kind of assets that we call solutions, circuits, or flows. Okay. The solution for us is the box inside we connect the quantum technology you want to use and the assets that will compose the quantum solution, the application at the end. So the first step is to create the solution. In the flow, the next step is create the circuits that solve some kind of quantum algorithm, and the end is the creation of the flow. The flow is the main program in which we can orchestrate how the different circuits we have created can be executed into the final platform defined into the solution. So first of all, let me create a solution. To create a solution is as simple as go to the solutions catalog and push the button of create solution. In this case, let me create a solution that we will call AWS solution. Let me write something in the description and click on save. In this moment, we can choose the platforms we want to connect to our solution. For that, let me click in the button platforms, and here we can select different technologies like QPUs or simulators that can be installed into the Quantum Path infrastructure or running into the Amazon Braket infrastructure. Well, we have to have in our mind that to create a solution, we must choose one of the two different technologies that are today available to execute some kind of quantum algorithm. These are the quantum gates technologies or the quantum annealing technologies. In Quantum Path, you can clear the devices to begin to select what kind of providers you want to use in your solution. Because I want to create a gate solution, let me click on the populate gate devices. This loads all the providers that are compatible with this kind of technology. To make the demos, let me select the Amazon Braket local simulator. It's a simulator that runs inside the Quantum Path infrastructure. And let me select, for example, the SV1 and the Amazon Rigetti SPEN 11, for example. These two machines are running into the Braket infrastructure. Okay, when you choose a local simulator, you don't need to specify some kind of credentials to execute your experiments. But if you want to access to the Braket infrastructure, you need your user ID and your password and some kind of token to prepare the connection. To do that, it's important that you have prepared your connection to the Braket infrastructure. To connect to some kind of QPUs running on the Braket infrastructure, you need to know, first of all, the region inside which this machine are running. You need an S3 bucket ready to store the experiments that you run inside the QPU. And then you need a user really configured, properly configured into the AM with the user and password created as token to access to your infrastructure. Once you have that, is to prepare the solution, you only need to click in the machine you want to include in the solution and click on the edit button to edit this kind of information. So for that, let me one instant to, sorry, I lost the word. Let me 1 minute to copy all my information. So let me fill in my user. Let me enter my password. And Knowing that the simulator can run in different regions, I will prepare my token following the rules in which we first specify the region in which the GPU are located, and then we put the token with the name of the bracket S3 in which Amazon will store the results of the experiments. Once I have filled in, I can click on update, and I have set up this connection. I will do the same with the Amazon bracket Rigetti Aspen. If I click in the edit button, I have the same screen in order to store the connection, okay? And I will put same user. I will set up my password. And I will put the token. In this case, we must put the note that you need to specify the US West one, that is the region in which Rigetti runs their GPUs, okay? So taking this in mind and specifying again the S3 bucket, I can click in update and I have ready my environment in the Amazon bracket part. Once I do that, I can click on close, I come back to the list, and if I have multiple solutions in my store, I can filter as you know in whatever environment you have managed before, okay? If I click on the AWS solution gates and click here, we can see that these platforms are selected from all we have available in Quantum Path. So let me go to the next step. So once we have created the solution, the next step is create the circuit. To create the circuit, it's as simple to go to the Quantum Circuit catalog and creating the Create Circuit button. In this case, let me create the groove name circuit. The namespace, we want to create some kind of taxonomy for these components to make unique in case you are working in a big team. So let me create the namespace AWS gates. Then the solutions we map to link, in this case is the AWS solution gates. That is a solution we have created before that connects our circuits with the Quantum bracket infrastructure, okay? The technology we want to use is the Quantum gates, and then we need to start to create the circuit body. If we click on the edit circuit, we can edit the circuit from scratch, in which you can drag and drop the different gates we have available into the Quantum Path Quantum Compositor, okay? But to make it fast, let me copy some kind of block of visual language. We can copy here and put it here directly. And then let me click on the edit circuit button. In this case, we could see that the visual environment can render the circuit I have pasted into the box. And this is the circuit for the growth algorithm that led us to search some kind of values into a structure with a string of information, okay? In this case, we are putting in the system different random values of entry. We will repeat the experiment 100 times, for example. And in the Oracle, we are specifying that we want to search the 6 value. The 011 value is equivalent to the value 6. Well, the growth algorithm tells us that we can set in some way the value with a mark that we are searching using the amplitude. So when we launch the diffuser, we are making that the probabilities of this value that we are searching for are amplified in terms that if the value that entered in the system is 6, working with the amplifier, the amplitude, we can modify the values that are marked to put on the top of the probabilities we are searching for. So in a really fast way, we can search whatever values we have entered in the system, only specifying in the Oracle what kind of values we are searching for. So dragging and drop, you can put the gates as you need, following whatever paper you have of the growth algorithm. And we have to mark in this case that we have these kind of gates that are virtual gates that let us the possibility to repeat some kind of blocks inside the algorithm. Okay, to do that in other technologies, you need to create some kind of loops or something like that. But in Quantum Path directly in the Quantum Designer, you can specify what kind of blocks you want to repeat, and the system will repeat these blocks for you. So it's really easy to create complex algorithm based on gates. Once I have finished my algorithm, I can click on Save Changes and Close. And in this moment, oh, let me see, I am losing, when I copy and paste, I will repeat again, gates, I click on the solution we need to connect to, AWS solution gates, and then I will click on save. So once I have that, to validate that this is correct, let me click on compile, an asynchronous process inside the platform. Once I do that, we have translate the visual representation into an intermediate language. At the end, if you want to use, for example, the QSOA SDK, you only need to remember this easy way to represent the intermediate language when you create the circuit, okay? Then using the buttons of the compilation results, of course, wherever screen you are, you can show the telemetry and the results of all the actions that you are sending to the system. So once we have the circuit, the next step is to create the flow. The flow for us is the main method of a classical language, okay, in which we can orchestrate how we want to execute our circuit. To create the flow, let me create a flow. It's the same process like the creation of the circuit. Let me create the groove flow. In this case, the namespace, I will use the same aws.gates, okay? If you are working in big teams, this is a really good practice to identify the taxonomy of each object. And for the solution, let me select again the solution we have created before that is connected to the QPU of the bracket gates, okay? Then I click on the edit flow, and here Quantum Path assists me in the creation of the flow. So let me drag and drop these components, and it's as easy as connected dots. I will connect these dots, and we are creating a flow in which I will execute our circuits 100 times. So this will create probability, and this will give us a lot of information to see how the QPU returns the value we need in order to validate that the groove algorithm are making their job, okay? Once I have designed the flow, I can click on the Save Changes. I can click on the Save in my catalog, and once we are in the edition step, we can again compile the flow. If there's no problem, we will have the compilation details with the intermediate representation of the flow. Again, we can show the compilator returns, and important, the transpile action. When we want to run all the assets that compose a flow, we need to transpile. The transpilation process prepares everything that is needed in order that Quantum Path can execute the products of a quantum solution in the final QPU. Once the transpilation process has finished correctly, we can then go to our flow catalog, and selecting our flow, AWS Groove Flow, we can click on the Runtime Dashboard button. From the dashboard button, we can select all the QPUs that are connected to the solution. Of course, we can change that in whatever moment we need. And we can choose one or two or the three machines if we like. So we have the possibility to select on demand what platforms do we want to use, and we can run the experiment at the same time in all the QPUs that you have selected now. If I click on the run flow, these jobs will be launched into the platform, running into the backend, and we could see which of the executions finish more or less or fast in terms of disposition of the QPUs, okay? In the case of the Rigetti one, of course, we can wait a few minutes, or it could go a lot of fast like this moment, okay? Once we have get the results of the quantum machines, Quantum Path provides you the histogram of the results. In this case, we can analyze them in a JSON format that is standard for every machine you select into the solution, as we could see in the graphic button, the possibility to show the visual representation. So in this case, we can show the results we are searching for. And sometimes these results could be not okay in terms of that the QPU can have some kind of errors, okay? I select the Rigetti S-Pen, and in this case, the Rigetti S-Pen has some kind of problems with the noise, for example. In some cases, the results could be not as we expected. How can we know about that? If I click on one of the simulators, for example, you could see that in this case, the simulator of TN1 of Amazon Braket has sent us that the value 011 is correctly within 96% of exit. So we can compare in this case that different QPUs with different noise could give us different results. And for us, it's really easy to compare that only watching the results in our pane, okay? All of these results are stored in the system forever. So if you want to recover some of these results, whatever you want, you can do that. So this benefits, for example, the democratization of the access of the quantum machines in order to not continuously be executing experiment in these machines. So as create a circuit, create a flow, and link to different technologies is as easy as it could see in this demonstration. Okay. To again demonstrate another kind of technology we can use with Quantum Path, and I go fast here because it's the same process. It's the same if we use the annealing technology. For annealing technology, we have other editors that are called the quantum compositors for annealing technology, in which we can define visually the Hamiltonian to solve a problem. Okay, let me only introduce the problem we want to solve that is known as the knapsack problem. We have a bag. In this bag, we have a maximum weight we can fill in with packets. Okay, it's Amazon Prime Day, so we can talk about that. And we want to put inside the bag a maximum weight of 6 kilograms, and we want to maximize how many packages can be inside the bag. Okay, to do that, we have to define a Hamiltonian in which we put the rule of we want the maximum weight of 6 kilograms, and we want all the possibilities, all the packages that maximize the price we can put in these 6 kilograms. Okay, to do that, I can have pre-created the AWS QSOA solution, in which the solution anneal, in which I have selected from the Amazon bracket, the Amazon bracket local LSAC solver, and the Amazon bracket D-Wave Advantage System 4.1, both technologies of the D-Wave annealing machines. Okay, I create the solution and I link these platforms as I do that before with the gates of the gates matching. So the next step in this case, I have defined the AWS knapsack problem. If I go to edit, we have the same information that the circuit gates, but with the difference that we are using the quantum annealing technology. In this case, the visual representation and the visual intermediate language could change. If I click on the edit circuit, we have defined, for example, the parameter WB. That is the 6 kilogram we want to maximize. We can create different variables to make more mathematic the problem. Okay. In auxiliary data, we have defined two arrays, one that defines the different prices of the different boxes, and one array for the different weights of the different boxes. Okay. In the variables, we are defining the boxes, that is the class that contain the problem. And at the end, we need to define the rules of the Hamiltonian. The rule editor is really simple. And we have two rules. One rule to maximize the packet price, and one rule to define that the maximum weight we admit is 6 kilograms. To define the first formula, we only need to add to the editor of the rules. And with the other expression, we have different terms of the Hamiltonians we can create. In this case, we have created a Hamiltonian that defines that for all the prices we have, we can select the boxes with the weight. Okay, from 1 to the size of the boxes we have, that are 5. In the next case, we have defined the rule of the maximum of 6 kilograms. Of course, we can enter and edit this kind of formulas, and Quantum Path can add some kind of validation if we made a mistakes. If we don't find the right weight or we don't find the right boxes, Quantum Path in its editor can help us with some kind of intelligence editor. Okay. In this case, we have defined that we have the weights of the boxes, and these never go up the WB variable that, remember, are 6 kilograms. Once I have that, to finish, I can see the whole Hamiltonian. So your multidisciplinary teams can discuss about how we solve that, visually seeing the formulas that compose the Hamiltonian that will let us the best combination of boxes for the maximum weight and the over prices. To test that, let me click on Close, Save, and Compile. And again, if I go to the flows, we have previously defined the AWS knapsack flow as the same process as we do before. In this case, we have a simple flow that executes once this circuit. In the annealing technology, by default, we run the experiment 100 times. In this case, I go to compile, I go to transpile, and again, we have already to run our experiment into the annealing technologies hosted into the Braket infrastructure. So let me go to the AWS knapsack flow, click on the run dashboard pane, and in this case, we have connected to our solution these two QPUs. The first of all is the simulator of the Amazon Braket that runs locally in the Quantum Path infrastructure. And the next is the Amazon Braket D-Wave Advantage System.41. So let me click on the run flow. When this is run, we can see that we are in the task pane, can see all the executions we are launching to the Braket size. So using the Braket tools, you can see the telemetry of these jobs. You can see the results generated into the backend of the Braket platform. And of course, you can monetize all the executions. At the end, you can see here how the processes has been completed at the same time that in the Quantum Path occurs the same. So we have these two results. The first result is the local solver, and the next result is the D-Wave. Again, in Quantum Path, we create a unique histogram defined that is homologated through whatever machine you select into the platform. So in this case, clicking on the annealing solution, we can see graphically that the best combination of boxes is the box 1, 2, and 3. If we see this picture, we can validate that is the best combination. So we can mix the 3, 2, and 1 boxes, and at the end is the maximum price with the maximum size. Okay, so we can see that our experiment works perfectly in this machine in case of the Braket infrastructure. Here's our demo. I can talk about that. You can do the same we have doing in the UI with the QSOA API. The QSOA API at the end is the REST API we have in Quantum Path to access to all the backend functionalities using some language of high level like Python or .NET or whatever you want. We encourage you to access to our web pages to see a lot of examples around the QSOA API and how much benefits it can do for you. Okay, so let me return to the presentation. And to finish our presentation, me talks about what's next. Okay, if you want to try our platform, you can register for free into the free developer license to test it. Okay, there are freely to use. You have all the time you need, and the only limitation is that you can't access to the final QPUs. But if you want more information, you can access to our web pages and see how to access to the QPU of Braket, for example. Quantum Path is the core to something bigger. Stay connected to our websites for news and announcements into the next months. We are working really hard for the version 2 of Quantum Path. The quantum software engineering with Quantum Path does not end here. We are working to make better the visual tools, to make it more agnostic, new interoperability contexts, and the apps ecosystem to come. So thank you very much for your attention, and I hope that you enjoy with Quantum Path technology.
Thanks, Pepe. That was quite wonderful. In the interest of time, we could not show you the QSOA API, but we highly encourage that you go and try it out for yourself. Here's the link to get started with Amazon Braket. Go to amazon.com/braket. To experiment with Quantum Path, please go to quantumpath.es. We will post this links on the description, so you don't have to worry about copying them right now. With that, I'd like to thank everybody for joining this webinar. If you have any questions about Amazon Braket, please reach out to me. If you have any questions about Quantum and Quantum Path, please reach out to Pepe. We'd be very happy to answer your questions. Thank you for the demo and presentation today, Pepe.
Thank you very much.